here comes our second review video. And our second review video is going to be a little bit more difficult because it's going to be mainly focused on systems and factoring, which isn't exactly our most favorite thing, but they are skills that are going to be really important and are going to come up over and over again. So before we jump into systems, we're going to review how to write the equation in standard form, standard linear form. And why this is important, because if you notice here, ax plus by equals c, that is how we set up a system to solve it. And so when I look at number 1, our problem here is we need our x first, our y second, and then set equal to our number. So we need our x first, our y second, and then equal to our number. Notice that my x stayed a positive 7, my y stayed a positive 3, but I need to move the 5 over. Anytime you're crossing the equal sign, that's when you do the opposite operation. Otherwise, it keeps its value as is. All right, so that was our work to get it into standard form. So we look at our next one. Again, we're looking to put our x first. I have an x here, and I have an x here. So I'm going to move the x over, so it becomes a negative 3x. Now technically, standard form, your first leading coefficient should be positive, but we don't really pay attention to that. It's not that important. We have our y's. Our y's are going to come second, so we need to move this y over. So 8 minus 1 is going to become a positive 7y. And then we have it set equal to our number. So we have a 9 on the right and a 1 on the left. We're going to move the 1 over to the 9 because we want our number, our coefficient without variables, to be by itself over there on the right. All right, so that's what we need to do to get our equations set up and ready for our systems. There are 2 ways to solve systems that you learn, 2 main ways: substitution and elimination. Now, we generally are always going to use elimination. It's not that you can't use substitution. We just I find it to be easier. So generally when I'm demonstrating, I will demonstrate in elimination. It doesn't mean that that's what you need to use. So I look at my options. I have x's and I have y's. I want to eliminate one of those 2 variables. And to eliminate, you need to get opposites. So the same number, but one positive and one negative. The x's, if I wanted to eliminate the x's, I would need to get the least common multiple, which would be 10. I would need one to be a positive 10, one to be a negative 10. That would require more work than the y's. Right now I have the same number, but they're both positive. So what I'm going to do is I just want to make one of them negative, and it doesn't matter which one you do. I'm going to make the top negative, just because. But what you got to be careful about is that negative needs to go to all 3 pieces. A lot of times we forget to distribute to the last piece on the right-hand side of the equal sign. So that becomes a negative 2x, a negative y set equal to a negative 10. Now we didn't make any changes to the second one, so that's just going to stay as is. And we see that a positive and a negative y equals 0 y's. And since I have 0 y's, that's what created that elimination aspect. Then we do a linear combination. I just combine these pieces together. A negative 2 and a positive 5, that leaves me with a positive 3x. A negative 10 and a positive 19. I'm going to combine those 2 numbers. That's going to give me a positive 9. And then we divide by that 3 to find that x is 3. Now we do have 2 variables here. We have x's and y's. We've only solved for the x's. We need to go back and solve for the y, which is really easy. We can go to either one of the original equations. Let's just pick the first one. It doesn't matter. So that becomes 2 times x. We're going to substitute that value back into this equation. Plus y equals 10. 2 times 3 is 6. We move that 6 over and we find that y is 4. You will also remember back from Algebra 1, another way that you solved was by graphing. And this was actually representing an intersection point on your graph. So sometimes you'll also see this written as an ordered pair because it's representing where that is on the coordinate plane. All right, let's move on to the next one. We want to eliminate. And again, we look at our options. We've got a 4 and a 3 for the x's. We've got a 6 and a 4 for the y's. There's no easy fix like there was in number 3. I could choose to do the x's or I could choose to do the y's. Now, personally, I'm going to do the y's only because I already have one positive and one negative, so I don't have to worry about distributing a negative. But you could do the x's. You just have to make sure that you multiply one of them by a negative. The least common multiple here is actually 12, because 6 times 2 is 12, 4 times 3 is 12. You could just multiply the top by 4 and the bottom by 6 as well, and to get 24, and that will get you the same answer. You'll just be dealing with larger numbers. Oops. I said 6, and I wrote it. So 6 times 2, that's where the 12 comes, so this needs to be a 3. We distribute that 2 to everything on top, so that becomes 2 times 4, which is 8x, 2 times a negative 6, which is a negative 12y, equal to 2 times a negative 50, which is a negative 100. Then we distribute that 3 on the bottom. 3 times 3 is 9x. 3 times 4 is a positive 12y. And 3 times 22 is going to be a positive 66. So our whole goal there, again, a negative 12 and a positive 12, that gives me 0 y's. So that eliminates. And then we combine 8 and 9 is 17x. A negative 100 and a positive 66 is a negative 34. We divide by 17 to find that x is going to be equal to a negative 2. Now to finish it off, we've got to go back to the beginning. You can choose either one. I'm actually going to choose the second equation. We just have smaller numbers and less negatives here, but it doesn't matter. So 3 times x, and again we found that x was a negative 2, plus 4y equals 22. Negative 6 plus 4y equals 22. We move that 6 over, again that opposite operation. 4y is equal to 28. We divide by 4, and y is 7. Don't forget that this could also be seen as negative 2, 7. Ordered pairs are always x comma y, so whatever the x coordinate is, comma the y coordinate. All right, let's go ahead and switch gears. Now we're going to look at factoring. So we're still looking for what we call standard form, but this time we are looking for quadratic standard form. So system of linear equations is when everything's to the first power. Now we have x squareds, and that is where you have x squared, the x, and then the number set equal to 0. We want to go ahead and rearrange. We want our x's to come first. So I'm going to move, the x squareds to come first. I'm going to move that 3x squared over. 7 minus 3 is going to give us 4x squared. Then I see my x's next. So I'm going to move the 2x over. 6 minus 2 is going to give us a positive 4x. And if you notice in your standard form, it's set equal to 0. So we want everything to be over there on the left. So I need to move this 5 over. Now I have it in standard form. 4x squared plus 4x plus 5 equals 0. This is the way we need to use it for factoring. We always have to have it set equal to 0 if there's an equal sign. Now into some factoring. When you factor, we notice that all of these have leading coefficients of 1. That's what we're going to focus on today. You're just basically playing a number puzzle. We're looking for two numbers that multiply to the outside and add to the middle. When you're trying to figure this out, we are always going to start with the multiplier first. So we think about all the different ways we can multiply to 16. 1 and 16, 2 and 8, 4 and 4, and that's it. We also have all of those, and if I multiply into a positive, a -1 and a -16, a -2 and a -8, a -4 and a -4. So we actually have 6 different ways we can multiply to a positive 16. But now we need to choose which one of those is also going to add to a -10. That adds to 17. That adds to a positive 10. Now this is kind of okay, we're almost there. So I'm going to go all the way down here. Same two numbers, but they're both negative. So a -2 times a -8 gives us that positive 16, and a -2 plus a -8 is that -10. So these are the numbers I'm going to use. When we set that up, we set it in the parentheses. And since it's a -2, it's x minus 2, x minus 8. Know that this is the same thing as x minus 8 and x minus 2. It doesn't matter which of those factors you put first. So just remember, we're multiplying to the outside and adding to the middle. So if I want to multiply to a -18 and add to a -3, these numbers are going to be a -6 and a positive 3, because -6 times 3, -18, -6 plus 3, -3. Sometimes these throw us off a little bit. Think about if I'm multiplying to 5, there's only one way to multiply to 5. That's 5 and 1. So we've got x plus 5 and x plus 1. 5 times 1 is a -5. 5 plus 1 is a positive 6. Multiplying to the outside, adding to the middle. Now when we take factoring one step further, we're getting to the zero product property, which you know as ZPP. This is why we always set it equal to 0. Without it, we wouldn't be able to solve. What the zero product property does for you is once it's factored, so once you have them in factored form, these two sets of parentheses, you take each of them individually and you set them equal to 0 and then you solve. You can only do this once it's in factored form. And then it's back to a simple linear equation solving. Divide by 3, and we have one solution of 3. We move the 6 over. So it's either going to be 3 or it's going to be 6. It can't be 3 and 6, but both of them are options because they both do work. And the last one, number 10, notice my directions. They changed a bit here. It says multiply. Sometimes we get into the groove of factoring and we forget when I see these parentheses, there's no equals 0. It doesn't say to solve. I'm not looking for the value of x. I'm looking to multiply here, which you probably know as FOIL. Multiply your first two terms. 4x times 5x, 20x squared. 4x times -1, -4x. This is just the distributive property. And now we distribute the 3 to everything, to the right. 3 times 5x is 15x. 3 times a -1 is a -3. Once you distribute the 4 to everything to the right term and the 3 to everything to the right, then you combine your like terms. I only have the 1x squared term, so that stays as is, 20x squared. Both my middle terms are just x's, so I can combine those. A -4 and a positive 15 is going to be a positive 11x. And then just your one coefficient at -3. So I've multiplied. Multiplication of these is actually the opposite of factoring. Factoring is when you start in standard form, like we did up here. So if I start in standard form and I go to factored form, I'm factoring. If I go from factored form to standard form, I'm multiplying out. So just be careful and pay attention to what the directions tell you to do. All right, that is it for our second review for Algebra 1.